Hi everyone, I am Madhu. So friends, today we are going to discuss about question number 4 from exercise 7.1 of chapter number 7, triangles, class 9. So the question is, L and M are two parallel lines. So as you can see in the figure, L and M, these both lines are parallel, intersected by another pair of parallel lines P and Q. So the parallel lines L and M, they are intersected by one more pair of parallel lines which are P and Q. So they are intersecting them. Show that triangle ABC is congruent to triangle CDA. So we have to show that triangle ABC, this triangle is congruent to triangle CDA, this triangle. So we have to show that these both triangles are congruent. So first of all we will write in triangle ABC and triangle CDA. So in both of the triangles, what you can observe that these both lines are parallel. So this angle will be equal to this angle. Angle BAC will be equal to the angle DCA. Why? Because they are alternate interior angles. This property we have studied in chapter number 6, lines and angles. That whenever two lines are parallel and they are intersected by transversal, here the transversal is AC. So the alternate interior angles are always equal. So these both angles will be equal. So hence we can write angle BAC is equal to the angle DCA. And what will be the reason? It will be they are alternate interior angles. So the reason is they are alternate interior angles. So one property we have got, we need two more properties here for proving the both triangles congruent. So now you can see that this line AC, this AC is common in both the triangles, in the triangle ABC and as well as in the triangle CDA. So AC is common in both the triangles. So we can write AC is equal to AC, and the reason will be it is common. So we have got now two conditions. Now we need one more condition. So you can see that if these both angles were alternate interior angles, this angle and this angle will be also equal because they are also alternate interior angles. So hence we can write that angle DAC is equal to the angle ACB. So we will write angle ACB is equal to the angle ACB is equal to the angle DAC, and the reason will be same as here it was. The reason will be same here also, alternate interior angles. So we'll write here the full reason. So now what we can write, therefore triangle ABC is congruent to triangle CDA. And by which congruency rule? So you can see we have got two angles and one included side. This angle, then this side AC, and then we have got this angle. So which congruence rule will be there? It will be ASA congruence rule, angle side angle, two angles and one included side. So they are congruent by ASA congruence rule. So this was the question. We have to prove both the triangles congruent. We have proved them congruent. So this was question number 4 from exercise 7.1. Now let's move on towards our next question.